In this video we are looking at what is a reference variable. Reference variable is actually quite simple thing. It's here. This is a reference variable here. So when we have this type on the left hand side, and then the next one is this ampersand, and then we have a variable, we know that this is a reference variable. So these two together, type and the ampersand together, is going to tell the compiler that the next one here is going to be a reference variable. So what is reference variable? Let's see an example here. So here we are creating an integer a, and we are setting a to 5. On the next line we are creating a reference variable b, and we set it to reference to a here. So let's see what it looks like in the memory. Here's the memory, the same thing. So when we create a, now whenever we call a, it will use this memory block here, and when we are asking the value of a, obviously it will go to here as well, and it will take the content of this memory block. So 5 is the value of a, and later on in the code, if we are asking what is the value of a, it will go to the same place and take this 5 from here. When we are creating a reference variable here, it will be a synonym name for this variable. So b is also using this same memory block. So whatever a is, the b is also. So if we are setting a to 5, b is also 5. And if we are setting b to 10 later on, a is also gonna look at the same place and it's gonna take the same value. So they both are synchronized. They both having the same value, and they're just two names for the same memory block, two names for the same variable. It's very simple actually when this is understood what it is. It's very simple. We have just two different names using the same variable. And here I'm trying to here show that they really are dealing with the same memory block here, because if they are using the same memory block, they should have the same address. The address of the memory block we can ask by putting this ampersand before the variable. So I'm putting here ampersand before b and before a, and let's run this program, and we should get the same address values. As we can see, the address of a is here and the address of b is here. So they both have the same address in the memory. So that just proves that it's true, that they are gonna take the value from the same memory block. So yes. So here I can also I can show that it really works like that. So let me, for example, okay, and one thing more, that we always have to initialize a reference variable on the same line when we are creating it. So we have to do this one. We have to immediately tell that to which variable it's referring to. Like here, b is referring to a. So this is not legal. We can't even do it on the next line like this. This is illegal. If I'm trying to compile this, okay, I try to show this. I think. Just a second. So I think there's an here error message that build failed, one error, and it says here that error b declared as a reference but not initialized. So we need to initialize it when we are creating it. It's a syntax error if we don't, and so we have to tell that which one is it referring to. So let's now change b to 10. So I'm changing b to 10. So now the question is that what is the value of a now? And let's go back to the picture. So I'm setting B now. I'm setting B to 10. So I will change this here. I put 10, and then I will copy this value. So this is actually what happens here. I better use this one now. So because B is pointing to this block, so it sets 10 here. Okay. So what is A now? Well, A is here. A happens to point to the same memory block, so A should also be 10, because they both pointing to the same memory block. So let's see that it is really true. I will print A and B here, and we will see what is the value of A and what is the value of B. And surprise, surprise, it was true. A is really 10 and B is really 10. They both have the same value, and I only changed B here, as we can see. So they are synchronized 100% all the time. After this, there are two different names for the same variable. Like my name is Juha, my middle name is Pekka. So if somebody gives me £5, Juha have £5, but Pekka also have £5. So if somebody said that, Juha, how much money you have? I can say that I have £5. Then somebody else asks, hey Pekka, how much money you have? I have £5. So it's gonna be the same result, because it's just two different names I have. Or yes, that's what it is. It's just two different names for the same memory, or for the same object. So what is the benefit with this reference variable? One benefit where we are using it a lot is that getting output changing. One is to change the value of a variable when calling a function. So for example, let's say that A is 5 here. Let's call it change function, and I will create a reference variable here, reference, let's say W, and I change W here to 77. So if I now call this function here and I pass A here, so what is happening now? What is happening now? What is the value of A after this call? A is now 5, and I'm calling this function, and I'm passing A. Actually, what happens here, I already made a video about functions. What happens actually in the memory, somewhere in the memory, I'll put it in the comments here. When we are calling these, what happens here is that it will do this one, and it will set it to whatever was here. So this is what happens first thing in this function. When we call this function, the first thing what happens here is that it will do this one. It will create a local reference variable W and set it to whatever was here. In this case, set it to A. So now W is just another name for A variable. So when we are changing W here, we are also changing A. So A should be 77 here. So let's run this program and see if it's true. And we can see it is really true. A is 77. So this function is able to change that variable value inside the function, and that is very powerful, because we can send and it's able to change outside the variables values, and it is one way we can use it. Okay, this one ends this reference variable tutorial. Thank you for watching.